Let's finish up the worksheet looking at number 6. Not exactly the same as number 5, but a lot of mistakes are similar to the mistakes made in number 5 in that students aren't quite able to apply what I've been asking them to do to this question. And so as I go through the description of what I want you to do for this question, I want you to try to remember, hey, this is what he was asking of me during the video lecture and during some of the practice that we've already done. Try to pick out what you've already heard and hone in on that, because that's going to be the secret to problem-solving strategies in the future. So here we go. A certain piece of copper wire is determined to have a mass of 2.00 grams per meter. Again, that's not necessarily a unit we've heard of before, grams per meter, but hey, it's wire, so the unit makes sense. How many centimeters of wire would be needed to provide 0.28 grams of copper? And so the question is going to be asking for my answer in terms of centimeters. The piece of information that the question has given me is this 0.28 grams of copper. Now here's the thing. This copper that I have has a mass of 0.28, or at least I need to have a mass of 2.8 grams. If I take this, whatever this unit is called, this quantity is called, the grams per meter, I can set up a conversion factor with grams and meters, right? It's 2.00 grams per meter, so I'll have numbers for grams per meter. You wonder, well, it's grams per meter. Shouldn't grams be on the top and meters be on the bottom? No. Main reason, I need grams to be on the denominator of this conversion factor so that grams will cancel. And well, doesn't that break a rule? No, because remember what these conversion factors are. There are fractions that are equal to 1, meaning whatever is on the bottom is equal to what's on the top, meaning it doesn't matter if you flip them upside down or right side up, they still equal 1, and they still don't change the overall value of the calculation. And so from here I stick in the numbers. It's 2.00 grams per 1 meter. Now notice that the grams are gone and my units are now meters. And so I've gone from talking about a mass of copper into a length of copper. Now the question wants a length of copper wire, but doesn't want it in meters, it wants it in centimeters. And so for every 1 meter, I have 100 centimeters. Again, notice I have meters on a numerator and a denominator, so those can cancel. And now I know I'm on the right track because the question's asking for centimeters. That's the only unit I have left. Now all that's left to do is carry out my calculation. Now the way this is set up, I'm going to multiply all the numbers that are on the same level. So all the numerator numbers get multiplied together, all the denominator numbers get multiplied together. And once you've accomplished that, you divide the two. So we got some 1s in there, so that's kind of easy. So I'm actually going to plug into the calculator 0.28 times 100. And then I'm going to divide whatever number I get by 2. And that should be my answer. Let's get that calculator up here. Clear. So 0.28. Oop, that's supposed to be 0.28. 0.28 times 100. And then I'm going to divide that by 2. And my answer is 14 centimeters.